Okay, so we all love those disaster movies. You know, the ones where buildings crumble like sandcastles. But have you ever wondered about those real-life homes? The ones built to actually withstand nature's fury? Well, that's what we're diving into today. Disaster-proof homes in the U.S. Specifically how engineers are tackling hurricanes and earthquakes. Creating homes that can stand strong when disaster strikes. I mean, ever wondered how a window can withstand winds over 200 kilometers per hour? We're going to find out. So whether you're a homeowner or just love a good engineering feat, this deep dive is for you.
It's a fascinating field for sure. You see, the U.S. has this incredible range of disaster-prone regions. You've got the hurricane zones on the East Coast and Southeast. Then there's the earthquake-prone West Coast, especially California. And with climate change making these events more frequent and intense, well, it's pushing the need for innovative building techniques.
Exactly. So let's start in those hurricane zones, places like Florida and Texas. We're talking wind speeds that can exceed 200 kilometers per hour. To put that into perspective, it's like over 100 pounds of pressure pushing on every square foot of your house.
Yeah.
How do you even begin to design a structure that can withstand that?
Well, you have to understand how those forces act on a building. With hurricanes, you're dealing with incredibly strong winds that can lift roofs, tear off walls, even send debris flying like missiles. So the key is to create a structure that can distribute those forces evenly, so there are no weak points that could fail.
Okay, so it's not just about building a super strong house. It's about strategically engineering it to withstand the specific forces of a hurricane.
Right.
So how do they actually achieve that? What are some of the key features?
But let's start with those windows you mentioned. Regular glass would just shatter under those wind pressures. So they use something called laminated glass. It's actually multiple layers of glass bonded together with a layer of plastic in between. That way, even if the glass cracks, it stays intact, preventing dangerous shards from flying around. And it keeps wind and rain out.
Oh, so it's kind of like a car windshield. It might crack, but it doesn't completely shatter. That makes sense. But what about the structure itself? How do they make the walls and roofs strong enough to withstand those intense winds?
Yeah, you're right. The entire structure needs to be reinforced. Walls and roofs are designed to distribute those high wind pressures evenly. That way you prevent concentrated stress points. And one of the most crucial elements is something called a tie-down system. These systems anchor the roof, walls, and foundation together using a network of metal straps or cables.
It's like a giant seatbelt for the whole house, keeping everything from flying apart in the wind.
Exactly. These tie-downs prevent the roof from lifting off and the walls from collapsing inward. It's all about creating a unified structure, one that can withstand the combined force of wind and pressure. And in areas prone to both hurricanes and flooding, which is increasingly common these days, the challenges get even more complex.
Right, because now you're not just battling the wind, you're also dealing with rising water levels. So how do they address that? I'm guessing stilts or elevated foundations are involved.
Got it. In flood-prone areas, elevating the home is crucial, whether it's on stilts or a raised foundation. This helps protect the structure from being inundated by rising water. It's all about anticipating the potential hazards and designing features that address those specific risks.
So we've covered hurricanes, but now let's shift gears to earthquakes, which are a whole different beast, right?
Absolutely. With earthquakes, it's less about resisting force head-on and more about flexibility. The ground is shaking violently, so buildings need to be able to move with those tremors instead of trying to stay rigidly in place. It's almost counterintuitive. But flexibility is key to surviving an earthquake.
So like a willow tree bending in the wind, instead of rigid oak snapping under pressure.
That's a great analogy. And building codes in earthquake-prone areas like California, well, they mandate this kind of earthquake resistance. It's just too risky not to.
Makes sense. So how do they actually design homes to be that flexible?
One of the most interesting techniques is something called base isolation. Basically, the house sits on special bearings or springs. These allow it to move independently of the ground during an earthquake. It's almost like the house is floating on a cushion, minimizing the impact of the tremors.
So the house is actually moving during the earthquake,
Yeah.
but in a controlled way that minimizes damage. That's incredible.
Yeah.
What other techniques do they use to make homes earthquake resistant?
Well, in addition to base isolation, they incorporate a lot of flexibility into the structure itself. For example, they use diagonal bracing in the walls. This adds strength while allowing the walls to deform slightly without collapsing. They also use materials like steel, which is strong but can flex and bend without breaking.
So it's this combination of base isolation, flexible materials, and strategic bracing that allows the house to ride out those seismic waves. It's fascinating how they've taken this concept of flexibility and applied it to building design.
It is, and it highlights the importance of understanding the specific forces at play in each type of disaster. With hurricanes, it's about resisting force, but with earthquakes, it's about moving with it. It's a completely different approach.
Right. And that brings us to regional adaptations, because not every disaster-prone area faces the same threats. Sometimes it's a combination of hazards, like you mentioned, with areas prone to both hurricanes and flooding. What are some other examples of how they tailor these designs to specific regions?
Well, think about areas prone to wildfires, like California and parts of the West. These homes need to be built with fire-resistant materials, like metal roofing and stucco siding. They also often have what's called a defensible space around the property. It's a buffer zone, cleared of vegetation to slow down the spread of fire.
So they're essentially creating a fire break around the home, making it less vulnerable to approaching flames. That's smart thinking. But as climate change intensifies, we're seeing more extreme weather events in general. How are engineers and architects preparing for these evolving threats? What does the future of disaster-proof homes look like?
That's a great question. As climate change continues to intensify, the need for resilient homes is only going to grow. We're already seeing more extreme weather events, from hurricanes and wildfires to floods and droughts, and the design trends reflect that.
So what are some of the emerging trends you're seeing in the field? What's on the horizon for disaster-proof homes?
Well, one exciting area is the development of new materials. We're seeing a shift towards lighter, stronger, and more sustainable options. For example, there's a growing interest in using engineered wood products, like cross-laminated timber, or CLT. It's incredibly strong and renewable.
So you can be looking at homes built from super strong, sustainable wood. That's a far cry from the traditional brick and mortar.
Exactly. And CLT offers a lot of advantages. It's durable, it's easier to transport and assemble, which can reduce construction time and cost, and it's a more sustainable choice overall.
And I imagine these materials would also be more energy efficient, which is another big factor in sustainable building, right?
Absolutely. Energy efficiency is key. We're seeing more and more homes incorporating features like solar panels, geothermal heating and cooling systems, and smart home technologies that optimize energy usage.
It's almost like these homes are becoming self-sufficient powerhouses, generating their own energy and minimizing their environmental footprint.
That's the goal. And it's not just about reducing energy consumption, it's also about creating homes that can function off the grid if necessary. This is especially important in disaster-prone areas where power outages are common.
So imagine a hurricane hits, power goes out, but your home can still generate its own electricity and even collect rainwater for essential needs. That's a whole new level of preparedness.
Exactly. And it ties into another trend we're seeing, the rise of resilient design. This goes beyond just building a strong structure. It's about creating homes that can adapt to changing conditions and recover quickly from disruptions.
Can you give us an example of what that looks like in practice? What would a resilient home look like?
Think about a home with a green roof. It not only provides insulation, but also absorbs rainwater, reducing runoff and the risk of flooding. Or a home with a backup power system. That kicks in automatically during an outage, keeping essential appliances running.
Those are great examples. It's about creating systems that are adaptable and self-sufficient, so the home can function, even when the infrastructure around it is compromised.
Precisely. And it's not just about technology, it's also about incorporating nature into the design. There's a growing movement towards biomimicry, which is essentially looking to nature for inspiration.
Biomimicry, that sounds fascinating. Can you elaborate on that?
Sure. It's all about learning from nature's designs and applying those principles to human engineering. For example, engineers are studying the structure of termite mounds to design buildings that are naturally ventilated and temperature regulated.
Wow. So we can see homes that are literally breathing and adapting to their environment, just like living organisms.
Exactly. The possibilities are endless. We're also seeing a growing interest in using natural materials, like bamboo and straw bales, which are not only sustainable, but also have excellent thermal properties.
It seems like this whole movement is about blurring the lines between the built environment and the natural world, creating homes that are in harmony with their surroundings.
That's a beautiful way to put it. And it's a movement that's gaining momentum worldwide. People are recognizing the importance of living in homes that are not only safe and comfortable, but also sustainable and resilient.
And it's not just about individual homes, right? This trend is also influencing the development of entire communities.
Absolutely. We're seeing a growing movement towards creating resilient neighborhoods and even entire cities. These are communities designed to withstand all sorts of shocks and stresses, from natural disasters to economic downturns.
So we're talking about a holistic approach, where the entire community is designed for resilience, from the individual homes to the infrastructure that supports them.
Exactly. It's about creating interconnected systems that are designed to work together, so that if one part of the system fails, the other parts can compensate.
It sounds like a truly integrated approach, where the focus is on the well-being of the entire community, not just individual structures.
You hit the nail on the head. It's about creating communities that are not only safe and sustainable, but also vibrant and thriving.
This is all incredibly inspiring. It's clear that the future of home building is moving in an exciting direction. It's about so much more than just bricks and mortar. It's about innovation, sustainability, and creating homes that are truly resilient and adaptable.
I couldn't agree more. We're seeing this convergence of technology, design, and environmental consciousness. And the result is a new generation of homes that are safer, smarter, and more in tune with the natural world.
It really is amazing to see how all these different fields are coming together to create these innovative and resilient homes. But I have to admit, when I think of disaster-proof homes, part of me still pictures those futuristic dome-shaped structures, almost like something out of a sci-fi movie. Are those actually a thing?
Well, you're not wrong to imagine those futuristic designs. They definitely exist. But a lot of disaster-proof homes are surprisingly subtle. They blend seamlessly into their surroundings, packing all that resilience under the surface.
So it's not all about those flashy spaceship-like designs. It's about taking these innovations and incorporating them into homes that people actually want to live in, right?
Exactly. Think about those hurricane-resistant homes we were discussing earlier. In places like Florida, you'll find beautiful beachfront properties. They look like any other upscale home. But look closer, and you'll notice the impact-resistant windows, the reinforced concrete walls, strategically placed shutters that can withstand those hurricane-force winds.
It's like they have a secret superpower, hidden in plain sight, ready to batten down the hatches and weather the storm, without sacrificing style or comfort.
That's a great way to put it. And these features aren't just for coastal regions. In areas prone to wildfires, you'll find homes built with fire-resistant materials, like metal roofing and stucco siding. They often have what's called a defensible space around the property, which is a buffer zone cleared of vegetation, to help slow down the spread of fire.
So it's almost like they're creating a mini fire break around the house, making it less vulnerable to those approaching flames. And what about earthquake-resistant homes? Are there any real-world examples of those base isolation systems we talked about?
Absolutely. In California, for example, you'll find homes built on these systems. They can quite literally ride out an earthquake with minimal damage because the house is able to move independently of the shaking ground.
It's still mind-blowing to me that a house can essentially float on a cushion of air or springs during an earthquake. It sounds like science fiction, but it's a reality for a lot of homeowners in earthquake-prone areas.
It really is remarkable how far these technologies have come, and they're constantly evolving. We're seeing new advancements in materials, construction techniques, and even smart home technologies that can detect and respond to potential hazards.
So it's not just about building a strong structure anymore. It's about creating a home that can actually think and react to its environment. That feels like the real future of disaster-proof homes, wouldn't you say?
I absolutely agree. We're moving towards a world where homes aren't just passive structures, they're becoming active participants in ensuring the safety and well-being of their occupants.
It's almost as if these homes are becoming sentient, able to sense danger and take action to protect themselves. And the people inside.
It is fascinating, isn't it? And it's all thanks to the incredible ingenuity of engineers, architects, and builders who are constantly pushing the boundaries of what's possible.
This deep dive has been such a whirlwind of information and inspiration. We've explored the science, the technology, the human ingenuity behind disaster-proof homes, and it feels like the future of home building is looking brighter, stronger, and more resilient than ever before.
I couldn't agree more. It's an exciting time to be witnessing these advancements, and I have no doubt that we'll continue to see even more remarkable innovations in the years to come.
So to all our listeners out there, whether you're a homeowner, an architecture enthusiast, or just someone who loves a good dose of ingenuity, we encourage you to explore this fascinating world, ask questions, imagine the possibilities, and see what the future of resilient living holds.
Because the more we understand about these innovations, the better equipped we'll be to create a world where our homes are more than just shelters. They can become true sanctuaries, able to withstand whatever challenges nature throws our way.
And on that note, we'll wrap up this deep dive. We hope you enjoyed the journey as much as we have. Until next time, Stay curious, stay informed, and stay resilient.